Hello! So today in this video I'm going to explain the difference between rational and irrational numbers, and then I'll show you step by step how to divide and add fractions using manipulatives. So let's get started. So the first thing that we need to know about rational versus irrational numbers is step 1. So what is a rational number? A rational number is any number that can be written as a fraction made from whole numbers. So let's look at an example here. So we are going to see we have 5, 6, -3, and 1.2. So these are all going to be rational numbers, and that is because you can turn them into a fraction. We see that 5, 6 is already a fraction. 1/3, or sorry, -3 can be -3 over 1. So for irrational numbers, this number cannot be written as a simple fraction, and its decimal goes on forever with no pattern. So this cannot be a number like 1/3 because it's going to be a decimal that is going to be a repeating of 1.333333 and so on, which is also represented by 1/3. And it can be other numbers like that that just continuously repeat. So what is an example of an irrational number? We are going to have the square root of 5, and we're also going to have pi. But we need to make sure that we clearly know the difference between irrational and those rational numbers. So the difference between a rational number is that a rational number can be written as a fraction, and irrational numbers cannot be written as a fraction. They are not the same. So now moving on to dividing fractions, we're going to be using paper strips. I didn't have any paper on hand, so we are just going to draw it, but it does the same thing. It's a paper strip, which I think is a very useful tool to use in the classroom, especially with limited resources. So here is our little paper strip here. This is our whole. We're going to divide it into 6 equal parts, and we are going to shade 5 of those parts, which is going to give us 5/6. And again, it is very important to remember that all of these are equal parts. They are divided evenly, and all parts are the same. None of them are bigger than another. So up top here we have the paper strip that we did in the previous slide there. So we have the 5/6. So now we are going to be working on a new paper strip, and we have our whole, and we are going to divide that into 3 equal parts. So if we had this in person, we would cut the 3, and we are going to color in one of them, and that gives us 1/3. But we want to know how many 1/3 pieces fit into 5, 6. So we have our 5/6 and our 1/3. So 1/3 is larger than 1/6. So I see how many third pieces fit into my shaded 5th, 6th strips. Sorry, that was a tongue twister there. Each 1/3 equals to 6. So we can see here in our little example, we have everything drawn out, and you can kind of see here how you can take this piece of the 1/3 and you'll see how it equals the 2/6 there. And if you take the 1/3 and if you part them out into half, so you pretty much double the amount of lines that goes through it, it would equal the same as if you did the 6. So those are how they're equal. You can split the parts of 1/3 and you can make it into 6. So that's how we got that there. So let's move on. So we had our 2 6 and they fit once inside the 5 6. 2 more 6s fit that partly. Then I have 1 6 left, and 6, which is 1/3, which is is half of 1/3 piece. That's how we got that up there. So 5/6 divided by 1/3 is equal to the 1/2 like we just said, which means 1 1/2 third pieces fits inside the 5/6. So I'm a slow writer. So this matches the rule keep, change, flip, also known as KCF, just as a little abbreviation there to remember a little bit better. So we are going to move on, and so this means that 5/6 divided by 1/3 equals 5/6 times 3/1, which is going to equal 15/6, which equals 2 1/2. So then for the final section, we are going to be adding fractions using a manipulative, and that manipulative again is going to be our paper strips. I actually find this really interesting when I stumbled upon it, so I really liked incorporating it. So we are going to be doing 2/5 plus 1/10. So here we have our first paper strip, and we are going to cut it into 5 pieces there, like we showed in our little example. And this is going to represent 2 out of 5. Again, we shaded in those 2 spaces. Those would be colored or cut. And we're going to cut all those parts and then color it in. So then for our second paper strip, we are going to have a hole, and we are going to divide it into 10 equal parts, and we are going to shade one of our 10s, which is going to be 1/10. So whenever we add fractions, we want to make sure to add the fractions, the pieces must be the same size. That is very important this whole time. When you cut your fractions with the paper, you want to make sure that they are cut evenly, just like you would with any block or manipulative that you use. So the common denominator for 5 and 10 is 10. Each fifth equals 2/10, so I take 2 out of 5, 2/5 paper strips, and show it as 4/10 instead. So 2/5 equals 4/10, and 1/10 is equal to, again, 1/10. And that is rational versus irrational numbers, dividing fractions, and adding fractions using our paper strips. Thank you so much for watching.